Well, good morning. Thank you for all of you who came today, and I know it's early, so I appreciate all you who got up early today. We're going to go ahead and get started. This is NVM Express State of the Union, and we'll also cover live migration. And so how about if we go ahead and get started here? So I'm Ross Stanford at Meta. Over here I have Mike Allison from Samsung, and we're honored to be here today, and I appreciate everybody's time. And with that, let's start off here and talk about the NVMe specification and storage. As you can see here, if you look at SAS, the analyst prediction is relatively flat. And you go to SATA, slightly increasing in time as you go out to, or decreasing, I should say, out to 2027. However, the dominant thing we really want to talk about here is NVMe and PCIe here. And you can see how the growth, in 2020 and, you go to 2023, it's rising, and how it continues to be the dominant interface here for storage. And that's great. Continuing on here, let's talk about petabytes and what is connected to NVMe here. As you see, enterprise continues to ramp. An interesting note here, as you look in 2023, we all know it was a very hard year for NAND suppliers. And you see that here, the 2023 numbers. See, enterprise actually dropped a little bit, and cloud dropped even more. But what you see is client really took off significantly here in this time. How a lot of those bits there you see in client. And then you see in 2024, things start to recover. And, if you go out 2025, you see cloud really starting to accelerate here, and you go out to 2027 and you see all these swim lanes look very healthy and are continuing to ramp NVMe as the dominant interface out there. Let's talk about the NVM Express organization. First of all, we have the board of directors. We have Amber Huffman. We have our treasurer, Curtis Ballard. I saw him here today, so I appreciate all his support. And Dave Landsman as secretary. Our technical work group chair is Peter. And the marketing working group, we have Cameron and Carrie. If I break some of the technical work group down in subgroups here, we have computational storage. We have fabric and multi-domain subsystems. We have the management interface. We have interoperability and compliance, NVMe OF, and we have erratas. And since Mike's our speaker today, feel free to ask him all about the errata task group. It's always good when things are right as opposed to close. We all know that. Our board of directors here you see it's a very healthy mix here between enterprise, hyperscalers, NAND suppliers, controller vendors. Very good mix of folks, all focused on making the storage ecosystem successful. Some organizational announcements. First of all, tools. We've been doing a bunch of updates with tools. We are now on Zoom and Causeway and Bugzilla. So moving to tools that many of you are very familiar with and use all the time. There's a website redesign. There's an errata task group. And there's also a software framework task group also going on. Next topic, modernizing the NVMe website. It's been a while. It's now been refreshed, the updated user interface. And so it's much more organized. So there's specifications, blogs, webinars. If you want to learn about NVMe technologies, there are a bunch of good options for you. You can go to the website, and there's educational information, there are blogs, there are videos. Many people learn many different ways and what's most effective. You can pick and choose what works best for you. There's a lot of great information there for you. So go to the NVM Express website and check it out. Now let's talk about the NVMe 2.0 family of specifications. There's the base specification, then there's the command set specifications, there's the NVM command set, there's the zone namespace command set, and there's the key value command set. Then there's the transport specifications. There's NVMe over PCIe, NVMe over RDMA, and NVMe over TCP. And then on the right-hand side, you see the management interface specification, and you see the network boot UEFI. And so by breaking up these things, you can see how it's nicely sliced and partitioned so you can mix and match based on what your needs are, and things can move ahead efficiently. Activity since the 2.0 specification. New authorized technical proposals, roughly 60. The ratified technical proposals, I think this number's a little low, but 69. As you can see, there's lots of activity going on here, lots of new things, lots of new functionality. Ratified ECNs. It's important to keep all those ECNs going because, things get found and we want things to be as accurate as possible and avoid problems. Let's talk about the roadmap a little bit. In green, you see the ratified features here. You see the NVMe OF automated discovery, the dispersed namespace, scalable resource management, network boot. You see the cross namespace copy. You see flexible data placement is there and ratified. Keeper IO. Then you see some things that are planned and coming. You see the computational storage programs, subsystem local memory, and live migration, which we'll be talking about more later on today. I should add flexible data placement. It's also going to be talked about in the Birds of Feather. So if you're interested in more of that, I encourage you to go listen to it. Let's talk about some of the specification advancements. There's flexible data placement. It's all about reducing write amplification, which then leads to improved performance and QoS and longer life devices. Then you have the network UEFI storage boot stuff. You have the computational storage. And let's also hit on live migration, about seamlessly moving data between machines. So those are some of the exciting things going on in NVM Express these days. And with that, let me hand it off to Mike to talk about live migration.
Hi, I'm Mike Allison. I'm a senior director at Samsung, and I work on standards, and I'm working as the lead author of the live migration that NVMe is currently developing right now. And what I'm here to do is just give you an overview of what we're trying to do and give you some insights as to our thinking. We're not done, so I invite you to come and join the party as we work through this. Effectively, what we're trying to do is take an SSD in one server, take the controller state and the associated attached namespaces and be able to migrate it from one server to the next. I'm saying server here, but if you're in NVMe, we would say NVM subsystem. So if I'll be mostly talking about NVMe here, but that's the ultimate what we want to do. If you go to Wikipedia and look up live migration, it breaks it up into 3 parts. One is a pre-copy phase, which is where you're going to say, hey, I want to take the namespaces, I want to take the static view of their current state, move them over to the other server, and then I want to track the changes that happen to that so I can play them back. It's kind of like journaling. You take a snapshot and then you replay your journals. And you keep playing that for a while, and then you get to a point where you want to stop and copy. And that's where you want to say, hey, I want to freeze the whole system. I want to do the final copy over, so as we're migrating from one server to the other, you can complete it, and then at the end, you got to tell where you migrated it to that it's time to go and move on. So I'm going to walk through all of this. This is all an animated slide here, so I'm going to walk through this very carefully so you can understand it. Before I do that, though, live migration is a complicated thing. We're breaking it down into multiple technical proposals. The first one is TP 4165, which was ratified last week by the NVMe Board of Directors. And what that allows is for a controller to track the LBAs that are actually allocated in a namespace, that have actually been written. So when you create a namespace, there's no LBAs actually written by the host, so they're all deallocated. There's nothing there. And then as they get allocated, you can track them. And then there's the get LBA status command that can be used to say, hey, what is actually allocated? The reason we broke this off is there's more than just live migration usages. If you're doing snapshotting and you want to actually snapshot a namespace, now you can say, I just want to go read what's really in the namespace. I don't need to read deallocated LBAs. What I'm going to be talking about here is TP 4159, which is the infrastructure for doing live migration. And we have more work to do there because we also want to look at trying to limit bandwidth and IOPS, and that's going to be a follow-on TP. So here I'm going to go and walk through what live migration is trying to do. So what we have here is we have a source host, and we're going to try to migrate controller Y into controller H. As you can see here, we're saying live migration, but from an NVMe perspective and a device perspective, the device is just providing services to the host. This is really a host-managed live migration. A host is doing all the work to move it from one server to the next. What we're doing in the controllers is to be able to read the state and set the state so the host can actually do the migration. Over here, though, there's going to be a special controller on each side. This is where the specialized commands come in for live migration to say, hey, send a command down here to say I want to control controller Y. I'm going to say admin host when I talk about it. And then this over here is this allocation map, which is that new TP 4165, tracking a namespace. So I have this namespace over here. These black bars indicate allocated LBAs that are in that allocation map. And we want to migrate all of this over to here while this VM is still running live. Okay? So the first thing that's going to happen is we have to say, I'm starting a live migration. And what's going to happen is a command's going to come in on the host source side and say, start migrating. And what that's going to tell the overall NVM subsystem here is that I'm expecting to migrate controller Y. And as part of that, we're going to create this migration queue. Now, I'm showing this migration queue outside because we're right now in the development of where we want to place it. So I don't have that information for you right now. But essentially here, this is where we're going to log the dirty LBAs or the journals of LBAs. And then down here is the static view of the namespace as we copy it out. So at this point in time, this command here is going to tell this guy, okay, start logging any LBAs that change. And when we say change, that could be due to a write or do a data set management to do a trim command. So at this point in time, I'm showing it here, but the host source can start migrating the VM because the VM itself has memory and its stuff has to do. And that could be migrated over. As part of NVMe, though, that's all part of the host that's outside of this, but I wanted to show it that the host can start migrating the VM, its memory map, and any change that it wants to do there in preparation for the migration. At this point in time, the migration has started on the NVM subsystem on the source side, and now we can do the new get log page status command that says, hey, get me the list of allocated LBAs. And what comes back is a list of LBA ranges, start LBA, number of LBAs coming back there. And then what happens is the host source, the source host can actually now start doing reads of the namespace, sending them over to the other server who can then do writes to the namespace. This is a static view, okay? It's just normal reading and writing, okay? So we already have that in NVMe very well. In the meantime, though, the VM is still running and a write command comes in. And when a write command comes in, it's going to write to the namespace. And it's also going to update the allocation map because that write's happening. So we always have this race conditions. You started migrate, you started a migration and the host is going to be copying over that, but a new write comes in and we got to make sure that that write gets accounted for. That's happening in the transition as he's making the static copy of there. So it could be in both the allocation map and in the migration queue as it goes along. But also now those LBAs change, so it has to go into as the journaling part of the dirty LBAs. So what happens over time? Lots of writes happen and maybe trims happen. And in the migration queue, we're going to have all of this dirty changes to the LBAs. They get put into the migration queue, and then the host can actually replay those, move them to the other server, and do those writes, read them and write them, and getting them over to the namespace in the other server. At some point in time, though, it's time to stop. I've copied enough over. I have minimal data left. I want to stop. So the first thing you need to do is freeze the VM. So that way we can stop getting commands being sent through. And then what we're going to do is issue a command to the source host and say, I am going to pause controller Y. At this point in time, controller Y is going to stop fetching commands out of the submission queues, and he's going to flush all commands out internally and post the completions for those and get to a paused state. At which point then, when the completion for that command comes back, the source host knows that that controller Y is now paused. No more commands are happening. It's in a stable condition. And now I can complete the final copy of the final state. So the host is free now to move over the rest of the virtual machine over to the server. And then it can finish playing back all of the dirty LBAs, at which point when he gets done with that, the namespace on the source should equal the namespace on the left. And then you can go on the source side and say, okay, go get me controller Y state. Okay, we're defining that now in NVMe what that means. But essentially it's a state that we want to go and put into controller Y so he can continue running the VM's workload on another server. So it includes, you know, the IO pointers into the IO queues and stuff like that. Finally, now that all of that is done, we can say, okay, go over there to the target host and say resume controller Y. You can let the VM run on the other there and they'll continue where it left off in the submission queues. And then you can send a reset to the controller Y on the source and reset that, and he's gone and we're running and we've migrated the whole thing. Now, again, this is in development. This is a really high level view of live migration. I do ask that if you're interested in this, come to NVMe. We're talking about it right now. And with that, any questions? Yes? Whoa. I hope my computer still works. All right, can you repeat that again?
Are you planning to follow this is for what you call popular migration and finishing plans on the switching? I think for can do it also for post-popular migration when you actually move the VM stuff running it, but still install it. So the flow will be different. So it needs some restart from there.
Okay, I'm trying. Why don't we talk afterwards? I'm trying to understand what you want. But if you,
There are two types of live migration.
Yeah. Yeah.
Then you actually finish synchronizing everything and then move to the destination.
Right.
Post copy is different. You actually move the VM, start running it, but then get there and so it only writes the new basically new NVMe, but you still need to move the old data.
Well, right now we're doing this version of here, but we'd like to hear some other inputs there. The problem is when you're looking at SSDs, right? The data's not in both places, and unless the host is going to do more across the point, then they have some options that they could do if they want to read from one server to the next. There is some possibilities, but again, from an NVMe perspective, this is the services to provide a host managed thing, and hosts can do some other things and use those services in other ways as well. Okay. Yes, sir.
So just for context, I'm always thinking about this in terms of TCP. So everything I say, NVMe on TCP, right?
Mm-hmm.
How do we specify the new destination after the migration? What options do we have?
Yeah. You're saying in TCP, repeat that one more time just so I get it clear.
So in the context of NVMe on TCP, how do we specify the new target for the migration that the host should connect to?
Right now, in this particular time, we're not addressing that in the TP because we're allowing the host in terms of how hosts target the different places, that's up to them and that's outside of the services. We're just providing services to read and get state and put, and how the host is actually communicating to those different services at this time, we're not addressing, and that's up to the host to decide how they want to do that. Yes, Randy?
One thing that might clarify things for people is that this is very much PCI SSD
Yes.
focus within the box. If you want to try and do that kind of migration, either the post copy migration or migration over TCP, you really should be looking at this first.
Yes. Yes. So the question is, how, if you're looking at NVMe over fabrics, how are you picking the target? And right now, we are addressing PCIe mostly here. We're intending that this is as we said, this is an infrastructure. We expect more TPs to follow on in relations to doing more things in TCP. But right now, we're just focusing on the simple services provided to provide accessing the data to be migrated and then doing the pausing and the continuation. Yes?
Yeah, so does the scan need to be done at any point, or is it zero downtime? Or,
The host has the option of how they want to deal with the VM. So the host can let the VM run. Our intent is that we're going to do a follow-on TP because if a VM is doing a lot of heavy traffic, maybe we can go in and throttle that traffic so the VM doesn't realize that it's being throttled. So we can get to a state that when you get to that final copy, you're at a minimal change state so you can migrate it freely there. The intent is to try to get as much copying done live in areas that may not be changing so you minimize the whole, I'm going to shut everything down, copy everything over, and then start back up.
yeah, but the contents of the VM memory has to be copied over. Right?
Yes. But again, that is controlled by the host. I'm not here to talk about the host. I'm talking about the SSD capabilities. But the host can do the same kinds of thing. They can take a snapshot of the VM, copy it over, and then manage what memory changes have happened. One of the features that we are looking into, and I didn't dive into this, is if a NVMe command comes in that causes the memory in the VM to change, that we're probably going to have a way to log that as well. And then you can play that memory change just like you would of LBAs.
That's about free copy paste in the observation program that you're asking about.
Oh,
Yeah, this is only for NVMe controllers, but this is not going to be the standard.
Yeah.
Except what Mike has explained.
Yep.
so one other question, sorry, a quick one. So in terms of drive specification, what features are needed to support this?
So he's asking what features are needed to support this. So we've already ratified TP4165, which does the allocation tracking. So that way, when you do the initial static copy of the namespace, you'll know which LBAs actually need to be copied and avoid copying over data that has not been written by the host. Okay?
In terms of the NVMe spec, which features need to be supported by the NVMe?
Well, in this particular thing, we're defining new features that are going to be supported. So there's going to have to be a new command that allows you to pause the controller, a new command to allow you to resume the controller. And that's what we're actually defining here. And I'm not at liberty to give you all those details at this time. Come to NVMe and you can help us figure that out. I have an inkling, you can talk to me afterwards, but we're in the middle of the development. Yes, sir.
So I'm just trying to understand, are we migrating simply the namespaces to a new server, or are we migrating everything over to a new server and a destination SSD?
We're allowing the host to migrate the contents of any namespaces attached to a controller from one server to the next, the entire namespace. So it looks identical by the time you migrate over, but we're also talking about the controller state. That way the controller understands the submission queues and where it left off. So at some point in time, the VM's going to be running and submitting messages or commands into the queues, and we're going to say, hey, controller, stop fetching, so we know where that is, and there's a tail and a head pointer. All that stuff has to be migrated, so when the VM starts back up, the workload just continues to be executed where it left off. The VM is not going to see anything. It's going to say, I submitted commands, and then I got stopped, and I got migrated, and I got completions at a later time. I'm just on a different server, on a different SSD. Yes. And the intent there is you can migrate between different vendors as well. Okay. Paul, you had a question?
I was just going to comment, it's the controller itself is migrated. So
Yes.
Yeah, might use the term of not subsystem, but
Well, we're migrating the controller, its state, and any attached namespaces that go along with that, because when you start the VM on the other side, he still has to see those namespaces attached. He still has to see the same NSIDs there, because he submitted commands with certain namespace IDs that identify the namespaces for the commands he's already submitted. Yes, sir.
Two questions. One is the false state, can you still do read? And the other question is the delta Q of the changes, is that resource constrained by the implementing device, or is there a limit in the system?
Okay. So the question is there a constraint on the migration queue? And I got stuck on, what was the other one?
The other one is the false state.
Yes, pos state. And in the pos state, can you do a read? So first of all, the commands being sent by the host are not actually given to the controller that is actually being migrated. So another controller is used to do all the coordination and all the reading to migrate over. So the reads of the namespaces are still allowed on other controllers. Okay? So reads will still work there. As far as the queue in there, we're looking at that now. What we're thinking there is it's going to be a real queue with a tail, and if the host doesn't pull them out fast enough, it could pause the system, is what we're thinking right now. So those are some concepts that we're doing. Another approach is you could have a bitmap which aggregates changes and you don't have any pausing. So those are the things that we're looking at right now. Good question. Thank you. So there was a question about reading from there. Why would you want to do that? Because you already migrated at that point. From an NVMe point of view, if the namespace is attached to another controller, it could still read that namespace. It's still an existing namespace. Okay. Any other questions? Good questions. Yes.
Yeah, are you thinking of extending this to, for example, live review environments?
We haven't had any. Yeah, we haven't had any of those discussions at this time, but my expectation is as this infrastructure gets in, we're going to look at the whole ecosystem and we're going to find that other people have use cases and they'll bring in a technical proposal to expand it. And then go ahead, Paul.
I was going to say, do reservations mess this up? Do you have to tear those down first, or do they get migrated too?
I don't think we've looked at that yet. So that's something to send me an email, Paul. Paul asked about reservations, whether they have to be migrated as part of the state. Again, we're still looking at the state. What does it encompass? And I have a feeling we're going to do we're going to have vendor-specific data as part of that. So if people want to do some vendor-specific things, they're allowed to do that as well. I do encourage you to come if you're interested in this. We're having some great conversations. It's probably been more exciting to me in NVMe than in a long time because it's been a lot of debate and a lot of fun. The other thing I do want to say is the new errata group in NVMe. I don't think you guys realize, or maybe some of you do because you're here, writing specs is hard. Writing specs for the world is hard. And all the engineers have a different viewpoint, and we really try hard to write a spec that can be read by any of your engineers, and they don't have to call your representatives to the organization to say, what does this mean? So part of the errata group in NVMe was to field the questions that we get and make sure that we can take those viewpoints and do the errata that we need to do to make sure that the spec is well understood worldwide. And that's where we're using Bugzilla now. Before it was all email and we lost things, and now we just put them in and we do bugs and we do errata and we work on them. And we have a really good group working on them to do the clarification. So, yes? In the migration right now we're currently looking at potentially using some stuff for the migration queue. Otherwise, everything's command-based, so you get the completion of the command and you know that the next stage is done right now. Yes? The question was, are there any new asynchronous events being defined? And the answer is maybe for the migration queue, but everything else is command-based, and the completion of the command will indicate the state to the host.
So I was more asking the AERs that were posted by the source guy, will they be handled and migrated over?
These are commands that are not
Completed, and we're discussing that right now. The current thing right now is we're not going to put that in the state at this time. We'll probably do a follow-on TP, and if you want that, we'll probably put that in the vendor specific. But again, we're still figuring out what that controller state is. So you're talking about the outstanding asynchronous request commands. Yes.
And the admin queue stuff is also outside of this.
Currently, right now, we're going to do a follow-on on the admin queue stuff. We're just putting in the infrastructure to have the base stuff in there. The problem is, if we do everything, it's going to take forever to get it all done. So we're trying to do it in steps as we go along the way. Yes?
Sorry, so what if multiple virtual machines are accessing the same LTA that
Since this is host managed, the host gets to define what it wants to do. So if you have two VMs that have attached the same namespace, it's up to those VMs to do coordination of changes. So from an NVMe point of view, we're just looking at the controller and the attached namespaces there, and they can be migrated at the control of the host. If the host wants to start sharing namespaces, then the host has to be prepared that those VMs have to have a coordination between them during the migration. Okay? Now the intent is we're not currently limiting the number of migrations yet. Okay? We're hoping that we're doing more than one migration at a time. So for example, if you have an SRIOV with 64 or secondary controllers, then why do we have to limit, and you could migrate all of them? Maybe you're going to do a service of a server and you want to migrate the workload off to do service on the entire server. You could do that. Mm-hmm. All right. No more questions. Thank you for your time. If you have anything else, I'll be here all week. You can come and ask me any question you would like on it. Thank you.